Okay, everyone, welcome again to the next lesson. Okay, as you know, we still in the middle of probabilistic modeling. Okay, okay. Now we come to the third part actually. Okay, third part of the technique under probabilistic modeling. Okay, now we look forward what is Markov chain? And why it is quite interesting to see Markov chain in many scenario actually. And sometimes if you start to look at different other people doing this Markov chain, you now see there are lots of different types of Markov chain. Sometimes you may even see the word hidden Markov chain, or maybe some other more illustrative, bombastic names, okay, that represent the Markov chain because it's interesting. It's an interesting technique, um, and it can be utilized in so many different so many different application. Okay, the main important issues in Markov chain because it is a random process. Okay, and it involved with the probability. Okay, that's why it falls under your probabilistic modeling. Very interesting this particular technique. Okay, why that is so? Okay, we will look further. Okay, and as I always mention, this is the opening door for you to know a little bit about some of the techniques available out there. Okay, so now we talk a little bit about Markov analysis. Okay, uh, as I mentioned earlier, the most important part about Markov analysis is on the probabilities. Okay, the different part of it is because by doing Markov analysis or Markov chain, we are able to foresee the future occurrence by calculating or by having only current known probabilities. All right, okay, because if you notice on the previous technique, for example, what we have is actually the time series data. Okay, or estimation, for example. Okay, but in this case you already have the probabilities. You do some digging, and then by having these probabilities, as long as you have the state. Okay, I'm going to introduce a little bit further about state in this problem. And then once you have the state, and then you identify the probability, and you make a little bit of assumptions there, and then you can use these particular assumptions and also your knowledge on your current probabilities to foresee future probabilities. The interesting part about the Markov analysis is that you don't need that much probabilities. All right, you only need the initial condition of probabilities, and also you need a little bit of a transition matrix. Okay, that one is also I'm going to talk a little bit more. Okay, at least you have these two, and then you're fine. You can predict whatever happen in the future occurrence. All right, and then you can see whether your behavior falls under the recurrent state, for example, or stability state, and so on. Okay, that one we are going especially focusing more on that on simulation sorry, on Markov chain part 2. Mm. In part 1 we are going to look at the technique, okay, the calculation part of it. Okay, and then how can we able to develop the transition matrix, okay, for you to improve your calculation in the future. Okay, as I mentioned earlier, you already know your present known probabilities, and then you have your initial states. Okay, states in this case is a condition actually. So, for example, you have one state, and then you have another state. And then the changing of this probability, okay, from one state to another, doesn't matter, one state to another, meaning that it can be either state one state sorry, if let's say you have two different states, all right, just simple calculation, you can either change your position from state 1 to state B, state A to state B, but at the same time you also need to remember state A also able to go to the same state A as well for the next period. The same thing happens for state B. State B can also go from state B to state A, or state B to state B also in the future. Okay, that's what make these things a little bit interesting. All right, to begin with. Okay. Okay, so what's most important is the initial states and also your transition probabilities. All right. So these are the assumption that I mentioned earlier. Okay. Unfortunately, as usual, we have to assume a little bit on the idealistic part of our modeling. Okay, because um, if we didn't have any assumptions, that means we can never make any modeling whatsoever. Okay, because of course you know that the world is very messy, and if you want to consider every other scenario and every other factors to consider inside your main mathematical modeling, you will never have any mathematical modeling whatsoever to reflect with your own systems. Okay, so that one I think you need to understand that. Okay, so again, it's better than nothing, right? Okay, so some of the assumptions that we need to consider is that our states are limited. Okay, of course, because if you're not having a limited states, how can you even develop a matrix, okay, a transition matrix? If you cannot develop a transition matrix, how are you going to calculate your transition matrix in the next period, in the next few periods, for example, let alone to let it run until how many occurrence to find the equilibrium point? You cannot do that. All right, so that makes sense. um, and then this one is also very idealistic. Okay, your probability of changing states remain the same over time. Okay, this is unfortunately a very difficult things to make sense. Okay, but again, as I said, this is your stepping stone. Okay, as long as we don't have any more information or any more improvement on the original system, unfortunately, we need to um, have these particular assumptions for us to focus on. All right. And then there are also another assumption, that the assumption is that by right we can predict any future states from the previous states and the metric of transition probabilities. And another one important criteria is that the size of the system do not change. Okay, but anyway, for example, if let's say you are dealing with a competition market, all right, it does not make sense, right? If let's say you have one situation, you have one system whereby your competitors are what, 3 to 4 players, okay, and then you assume that periodically speaking, okay, if you run the cost of your assumption, the competition of the market share, for example, until what, 10 to 12 years, you assume that your competitors still remains the same. If you start with three main competitors, another 10 years, you still have these three main competitors. There's no the incoming competitors coming in into the market share, okay, to compete with the market. No, it's a little bit far stretch, okay, but again, as I said, this is the thing that we have, okay, so we need to make do with these things. All right, so um but if let's say this assumption is met, and then you can just simply solve the solution easily again, okay, similar to your queuing system. As long as you identify your probability states, and then it's fine. Okay, so let me explain a little bit what is states and what is states probability, and also what is the transition metric, especially for those of you who this is your first time, for example, listening or having some information on the Markov chain. Okay, so states actually is actually the identification of all possible conditions. All right. So, why it mentioned there a condition of a process or a system? Because it does not limit into one particular knowledge or trajectory, for example. Okay, for example, I give you three different scenario. Okay, if you look at the example, I give you the first one, sunny and rainy conditions. Okay, that is a state. One, you have a sunny state, and then you have the rainy state. Okay, and then the same state, okay, you can use the same concept, you can use the same transition matrix, but the state now is different. Okay, now in this case, you are talking about a baby. Okay, a baby's mood, for example, it's either is in the state of awake, sleeping, crying, and playing. Okay, you see, this one is more on the social behavior, right? Okay, but the sunny and rainy condition is on the weather condition. It's completely two different branch of information altogether, but still, as long as you can categorize things into a state whereby, right, for example, it's either, okay, today you are sunny, tomorrow rainy. Okay, and then for example, child, uh right now she is awake, and then the next 1 hour she is sleeping, and then the next other hours she is crying loudly, and then the next hours is playing. Okay, the hours in that sense on the on the baby, that one is a period. Okay, but the awake, sleeping, crying, and playing, is the state. Okay, so the same thing if you are talking about the social standing. Okay, now you can move into a level of social hierarchy. For example, you have B40 group, M40 group, T20 group. Okay, so these are also the states. Okay, for example, if let's say the period of the state is especially when you talk about M40 groups, right? Is either M40 groups can suddenly becomes the next step, or the next period they goes into the B40 groups, or another type of M40 groups suddenly on the next period they go into the T20 groups. Okay, so this is the states. Okay, so you can see why Markov chain is interesting, because it does not have any limitation on whatever application that you can use. Okay, you can use it as long as you can identify the state, as long as you are interested to know whatever happened to the next future about the state. Can the state be changed? Can the state change according to time? For example, if you are interested to find the changes of state, okay, no matter what do you mean by state in your particular approach, then you can use Markov chain. Mm. Uh, with a slight things that you need to consider all the assumptions, the previous assumptions. All right, okay. So that is the important part. All right, that is the important part of Markov chain, which is the state. Okay, now we are trying to familiarize ourselves about the notation. Okay, if let's say you have this notation, okay, we just put pi over here. Doesn't matter. You can put A, B, C, or whatever. Okay, if let's say this is a pi, and then you have I, so it means that it is a vector of state probabilities. Okay, remember, we are talking about the probability inside the vector valuation. Vector valuation meaning that you have a matrix over here, right? It's a 1 by 1 2 3 4 1 by n, or n by 1, okay, whatever it is. Okay, meaning that you have a one line vector coordinate, for example. Okay, so these vectors representing your probabilities for your period I. Okay, you have to remember your period is not the same as your state. Okay, your state representing over here, this is your state. Okay, meaning that state 1, this is the probability for your state 2, probability for your state 3, and so on. Okay, whereas this one is the period Okay, you are talking about period. Okay, interesting, right? Okay, it's a little bit tricky, especially once you have a complicated system in place, right? But I think the idea is there. Okay, now, okay, so now in this case, if let's say you have pi one equal to one, pi one, if you have that one, okay. This is the first state. Okay, for example, your pi one is a vector of state for the machine in period one. Okay, and then the first element in your vector one is the probability of being in the first state, and then zero is the probability of being in the second state. Okay. You may be confused, okay, 1 and 0. Okay, you always have to remember whatever it is, we are talking about a probability. All right, so makes sense if let's say you have this kind of system. Actually, your when you plus 1 plus 0, you will have 1. Okay, so whatever it is, the summation of this value 1 and 0 becomes 1. Okay, because we are talking about probability here. All right. Okay. So now, it's easier, I think, to discuss on the example. On the example. Okay. Let's say we have a grocery stores, and then we have 10,000 people per shop. Okay. Ha. Let's say you have three different stores: store A, store B, and store C. And then you differentiate your store A by making sure that your store A is state 1, store B state 2, store C state 3. Okay, that one is clear. How are you going to get your first initial state? Okay, that one is not that clear. Okay, so in this case, how you can do that? One way is that you, for example, you go to these 10,000 people, you make a market survey. All right, you make a market survey, and then by the end of the day, when you make a market survey, you notice that out of these 10,000 people, 4,000 of them go shopping at store A, whereas 3,000 go shopping at store B, and then 3,000 go shopping at store C. Okay, that is your initial condition actually. Okay, so how can we able to translate this knowledge into a probability state? Okay, that is the most important part. Okay, so how you're going to do that? Oh, I'm sorry. This one is actually 10,000. Yeah. Okay, so how you're going to do that? You translate your knowledge into a probability. Okay, so by right, this one is easy, right? You have 4,000 from 10,000. Definitely, you have about 40% of the population of these 10,000 go to store A. Okay, the same thing for store B and also for store C. Okay, so you translate this into a probability, which your pi naught right now, okay, your initial condition in this case is 0403 and 003. Okay, like this. Okay, so this is your initial condition. Okay, so I put over here at the bottom of it for the rest of the slide, because I want you to remember again the initial condition, because we're going to recall these inputs. All right. Okay, so next. Okay, so next. In this case, we would like to know how their market share changes over time. Okay, so this is another market share survey, for example, meaning that, okay, if let's say you translate your market survey into a tree diagram, okay, we call this like this. Okay, for example, if you are a store A, okay, your customer in store A, the probability of your customer, your store A customer, your 4,000 customer, from this 4,000 customer, the probability of them going back to the same store, which is store A, on their next purchase, okay, for example, next month, they are going back to store A, 80% of them will do that. Okay, this comes from the market survey as well. Okay, so you need to, if let's say you need to create a questionnaire, you create the questionnaire that can give you this kind of information, so that you can tie back to your transition matrix. So in this case, have the you have the first stage. Okay, you know your preference, you know your the preference of the customers, which supermarket they choose. And then the next stage, you are able also to extract the information from their preferred choice on their first month, for example, going grocery. The next month, what will happen? Will they change their loyalty, or they stick to the same store altogether for the rest of the time? All right. So, based from this market survey, for example, you get the valuation whereby for store A, 80% of them will still stick to store A. Whereas 0.1%, which is about 10% of them, will go to another shopping store. Okay, 0.1 probability, which is about 10%, will go to number two, store B, and then another 10% will go to store C. Similarly, for customer in store B, okay, customer in store B will go to store A, about 10% of them. 70% of them will go to store B, the same store. And then another 20% will go to store C. The same thing happens for your C. Okay, so how to move about? Okay, how to move about? Okay, so once you have this once you have this information, what you need to do is, our intention is to try to construct the transition matrix. Okay, how to construct the transition matrix? We know we want a matrix, and we know inside the matrix there are all of the matrix inside there are all probabilities. Okay, so we need to extract all these probabilities. How to extract probabilities? Okay, so this one I'm going to introduce PIJ. Okay, PIJ meaning that the conditional probability of being in state J in the future given the current state of I. Why we call that conditional probabilities? Okay, as usual, I need to remind you again of your knowledge on elementary statistics. All right, so try to refresh your memories on that. Okay, conditional probability meaning that you cannot shy away from the previous probability that you have. That one is a conditional probabilities. Okay, because your further probability or your further actions is coming from the previous action. Okay, it is not independent. All right. Okay, so that is your conditional probability in this case. So, for example, if let's say you have P1, 2, meaning that it is a probability of being in state 2. Okay, if you notice, state 2 is the future state. Okay, given the event was in state 1 in the period before. Okay, so meaning that your earlier state is 1, your future state is 2. Okay, I hope that one is clear. And then once you keep on doing this, this is the final version of your transition matrix. Okay, or we call that what? Matrix of transition probabilities. Normally, people just say this as transition matrix, right? Okay, interesting so far, isn't it? Okay, now I'm illustrating. All right, I'm illustrating this kind of figure. Okay, because I want you guys to understand a little bit more. This one is actually just similar to the tree analysis earlier. Okay, it's just that on tree analysis, you couldn't see the behavior of your system. Okay, so that's why I'm translating your tree analysis inside this graph, because I want you to know that if you have a state A, B, and C, okay, these are the valuation. Okay, where meaning that if let's say you are at state A, and then when you go back to state A, Meaning that all the arrow is the transition of your state. Okay, from A to A is 80%, from A to B is 10%, from A to C is 10%, from B to A is 10%, from B to B is 70%, from B to C is 20%, and so on. Okay, so once you identify this one, it is easier for you to create your to create your transition matrix. Why I said that? Okay, now. Okay. Okay, it looks messy, isn't it? Okay, so this is your transition matrix right now. Okay, so you have your first line is referring for your store A, your second line for store B, your third line for store C. Similarly, you do the same one for your column, store A, store B, and store C. Okay, what is this? This one I put something like this. This is from and this is to. Meaning that you do it something like this. From A, okay, because this one is A, B, and C. Okay, from A to A, the probability is 0.8. Okay, see, from A to A, the probability is 0.8. Whatever happened from A to B, okay, the probability is zero point 0.1. See, from A to B, the probability is 10%, which is 0.1. And then let's say if you put in the middle like this, for example, this one, meaning that from C to B is zero point 0.2. From C to B, okay, here is zero point 0.2. 20% of the 100. See, that's why you have zero point 0.2 over here. Okay, I hope you digest that. Okay, so in the meantime, okay, you look back at the row 1, row 2, and also row 3, all this representing the same thing as I mentioned earlier. Okay, it's just that if you keep using your figure like this, it is easier for you to transform, okay, your valuation of your percentage into a probability in a transition matrix, easier for you to see. Okay, that's what happened. Okay, that's what I do. Okay, this one is the same. Okay, why we are doing this? Okay, why we are doing this? Okay, the idea, okay, the main intention of Markov analysis is actually forecasting. You want to predict the future. Okay, you want to predict the future. It's just that how are you able to predict the future given the prior initial conditions and given the probability that you know? That is the main story here. Okay, so later, okay, this one I'm going to show you how. Okay, so when you want to start predicting the future market share, for example, we are talking about market share over here because it's synonym with our problem here, right? Okay, you have three different market segment. Okay, you have 10,000 people, only 10,000 people, and all these stores struggling. Okay, they want to take all the people coming to their stores to shop, for example. So that's what we call a market share. Okay, so how to predict the future market share? Okay, we start the first step first. Okay, the first step moving forward to the future. Okay, so the first step, initially we have the first initial period, pi 0 for example, and then we start with the next period 1. Okay, so this makes sense, right? Okay, we have pi 1 equal to the initial condition p, and then we have this one. All right. Okay, so this one is also follows the same, right? Okay, if you have another step, n plus 1, and then you need another, the previous step, meaning that your n, okay, and the rest is just the same. Okay, so how to calculate that? Okay, first, you have your initial condition. So your initial condition in this case is zero point 0.4, zero point 0.3, zero point 0.3. That's why I put it over. Oh, sorry, this one is 0. Okay, that's why I put over there. Okay, so pi 0 is 0.4, 0.3, and zero point 0.3. and this is your transition matrix. All right. So once you have this one is 1 by 3 matrix. This one is 3 by 3 matrix. So by right, you have 1 by 3 matrix. Okay, so basically you do the calculation normally. Just multiply your matrix together. And then this is your final values for your period 1. Okay, your period 1 now. This is the market share for store A. This is market share for store B. This is market share for store C. If you look carefully, if you notice, this is our initial condition. Okay, for market A, okay, one step ahead, it gets the valuation from the customer coming from B and also C. We didn't notice that on the previous assumptions, right? Sorry, on the previous calculation, because it's in just like a figurative illustration, and also we look at it in the tree diagram, so we cannot capture exactly the next period what will happen. Okay, so you can see over here, actually, if you start capturing that one step ahead, one period ahead, um, you see store one, store A increase the valuation. Instead of zero point 0.4, now becomes 0.41. The same thing happens for your store B. Instead of the first state, you start with zero point 0.3, now it becomes 0.31. What about C? See, from zero point 0.3, now it reduced the market share into 0.28. Okay, that is not a good place for C right now. Okay, so this is only one step. And then you can see over here, if let's say the system again follow the same assumption as I highlighted earlier, you can actually predict what happened to these particular stores for the next 10 periods of time, okay, for the next year, depending on what type of period you are talking about. Okay, so that one is quite nice and quite interesting, isn't it? Okay, so if let's say you follow the previous formulation like this earlier, sorry, this one is plus 1 equals to pi n p. Okay, you notice if you increase from 2 to 1, if you increase from 1 to 2, okay, this one is also increased, right, from 0 to 1. Okay, so can we able to try to utilize our pi naught, okay, our initial condition. Okay, why I want to utilize pi naught, because if let's say you have, for example, you need to find the period where your period now becomes 10, okay, like this. And then how to get your period 10, meaning that you need to find your period 9, and then you need to find the transition metric. Transition metric, no problem. But if you need to find P9, pi 9, you don't have the information on pi 9, right? So you need to start all over again. You need to get pi 9, you need to find pi 8. And then once pi 8, you need to find pi 7 and so on. It does not make sense, right? So instead of trying to complicate your life, okay, now we try to utilize whatever happened if let's say we can scrutinize and transform a little bit what we already know previously. Okay, so how to transform it? Okay, we know that your p1 is actually just p not p, right? And then you have p2 is actually P1P, and then you replace your P1 with this P not P times P, and then you can see finally you have pi not P square. Okay, pi not P square. And if you notice, oh, square is just the same of square, isn't it? Okay, so by doing your inductive measurement, okay, when you know you have these particular relationships, by right, if you change any n into whatever value, it's still the same, isn't it? Okay, if you're not confident with that, that's okay. You can try to do for pi 3, pi 4, and so on. But trust me, okay, we can do this, right? Okay, so basically, we do inductive assessment, and then we can just simply transform or substitute your 2 with n, so it follows like this. Your p also with the power of n. Okay, so these are the million-dollar question. Okay, so the question is whether your store A and store B will continue to gain market share on, and whether store C will continue to lose. Because if you know, if you are unfortunately a store C, what is your strategy if you are being put into this kind of position? Losing is not that nice, isn't it? Okay, so this is what we want to do. Okay, this is what we want to see, the equilibrium and the steady states. Okay, so how to calculate the equilibrium and the steady states, we will look at it further in the part two assessment. All right, so but before we move towards that, okay, this is just a teaser. Okay, this is just the teaser. Okay, if let's say I want to check whatever happened in period N10. Okay, I'm not talking yet about the equilibrium, okay, because N10 is still not it's not that sufficient enough data to know that you are actually in the right place. All right, so this is just a teaser, okay, for us to look at the equilibrium on part two. Okay, if let's say you go into N10, you can just simply have this particular formulation. Your pi naught is just your 040303, and then this is just your available long p. Okay, you keep on multiplying the matrix to the power of 10. Mm. Okay, so by right, this is the 3 by 3 matrix. Your 3 by 3 matrix after this. Since we are dealing with, since we are living in this, in this fortunately a very, very good resource era. Okay, if you notice, I calculate this matrix, I didn't even calculate by calculator or whatever. I'm just going into the website and then see, and then I find the matrix calculator on the internet. Okay, and then I just put the valuation point 0.8, point 0.1, point 0.1, and so on, the rest of it, and then I just make it do a power 10 over there, and this is what I get. And then when I have the initial conditions, I just put another matrix and then multiply also in the same website, and then I get this value. Easy life, isn't it? Okay, so if you notice over here, company A looks quite promising, right? Instead of having the first initial condition, you have 0.4%, and then the next state it has about 0.41%. Now after 10 period of time, it gained a lot more. Okay, it is extracting customer from store C. Actually, the same thing happens for store B. Store B also extracting customer from store C, and you can see over here the loser is store C. I'm not sure if you are in a position of store C, whether you need to realign your strategy, because if you don't do anything, if you don't realign your strategy, or if you don't do slightly different approach, and you keep on doing exactly as the same assumption as I mentioned earlier, okay, you keep doing again the status quo, by right you are going to be diminished from the market share. Okay, if not diminished as well, because I notice, I think this one it is in a recurrent state. Okay, meaning that it will not going to be absorbed by another company, for example. But then it does not make sense, right? Because you know already that you only have about 0.26% of the market share compared to your competitors. Okay, even if let's say for example the competitors is about the same as you, It does not make sense, right? You need to stay competitive, right? Okay, so that is how we move about. Mhm. Okay, so I end this phase one with software in action again. It is not limited to QM for Windows, but since you're already familiar with QM for Windows, I just put it inside here. Okay, so you have the Markov analysis items on your left hand side. You just choose that one, and then you can just put all your you can just put all your initial conditions over here, and then put your transition matrix. This is your transition matrix over here. Oh, sorry. And then uh, click solve. And then voila, these are all the valuation that you have. Okay, so these are all the states that we have over here. Okay. And actually, you already have the final ending probability over here. Okay, but we are not going to touch on this in this particular juncture because we are still not talking about the equilibrium part of the Markov chain analysis. Okay, so I think that's about all for part one. I hope you enjoy the lesson and I hope you understand why it is interesting to know more about Markov chain and why Markov chain is a technique that is being widely used in so many applications outside, not only business, it's in the social, weather forecast and so on. A lot. Okay, and um, I would like to emphasize actually, if you're interested to know, okay, okay, if you look at Google, right? Okay, if you look at Google and you see Google talk about machine learning, isn't it? I mean, machine learning, what does it mean by machine learning? It means that it is able to capture or give suggestions. If you go to Google search, okay, suddenly without you even noticing, there are lots of information that you don't want to find, okay, but they give it to you. Okay, they give it to you preempt, okay, prior to your search engine. Okay, so that is what we call a machine learning. All right, and then the idea behind that, and the way Google see what type, which website that is more significant, for example, impactful, okay, not necessarily only because of the frequent frequent people visiting the website. Okay, sometimes it's because of the length of time people getting absorbed into this particular website and so on. Okay, but by the end of the day, they have this, I cannot remember the name. I cannot, but you can check on the on internet. They are actually using the algorithm behind that. They are incorporating Markov chain in part of their analysis, okay, to make sure that they understand the people's behavior towards the preference, people preference of certain websites. All right, so it's quite interesting. All right, so it jive with the digital transformation right now, and it jive with the machine learning AI and so on. Okay, so it is worth understanding the algorithm behind all this information because you may not know, okay, how are you going to use this, okay, capitalize on your knowledge on these particular issues, and then try to make full use of it. Mm. Okay, so I think that's about all for Markov chains. The sufficient information on it, and I hope you enjoy the lesson. I'll see you guys in the next lesson. Okay, all the best.